Yes, dear friends, the last topic is potentiometer. Uh, what is potentiometer? It is a device used to measure potential difference. But in doing experiment of Ohm's law in lab, you use a voltmeter to measure the potential difference. Then what is the need of potentiometer? I have drawn a diagram here. I are the resistance when and we connect voltmeter across conductor resistance R. When we connect, some current I dash is taken by voltmeter and on passing current I through the system. Current through resistance will be I minus I dash because I dash current has been taken by voltmeter. So potential difference, the voltmeter reading, if we measure potential difference across R, in fact, will be V equal to I minus I dash into R. In parallel combination, voltage potential remains same. But if no voltmeter connected, current through conductor will be I. Across R when voltmeter not connected, then potential difference. Yes, but according to Ohm's law, potential difference across R when voltmeter not connected on passing dial IR, which is greater than I minus I dash. So IR had been equal to IR if I dash 0. If voltmeter does not draw any current, then the reading of voltmeter would have been exactly according to Ohm's law. But voltmeter problem is that it always takes some current. Without taking current, it can't give deflection. And therefore voltmeter always reads less value than actual. How to make the reading nearly correct? But in Ohm's law we take the reading of voltmeter as potential difference, because what we do in fact, a voltmeter is high resistance device, so it takes very small current. If from 5 ampere it takes 0.01 ampere current, then difference is negligibly small, but difference is there. So voltmeter always reads less value of potential difference than actual. So how to measure actual potential difference? By V equal to IR equal to IR if I dash 0. So we have to construct a device which measures potential difference across current carrying conductor or electromotive force of cell without drawing current. In case of cell, if there is the cell, it has internal resistance, and if we connect voltmeter here, some current may be very weak, will be there, and then V will be equal to E minus IR. So that terminal voltage will be always less than the actual one. If I negligibly small, it will take. But whatsoever is, it is always less. This question is generally asked, explain why voltmeter always reads less value than actual. Because voltmeter draws some current from circuit and hence potential difference reduced below the actual value. Then how to make it? So we need a device which measures potential difference without taking current from the circuit, or we can measure EMF without taking current from the cell. Potentiometer is that device which measures potential difference without taking current. So here I think we have got the need of potentiometer, because voltmeter always reads less value than actual, because it draws always some current. So we need to construct device which measure potential difference without taking current, and that is potentiometer. Potentiometer is simply has long wire, a long wire of an alloy like manganese. Please note this, manganese alloy. I told why it is there, because resistance of manganese does not increase significantly when temperature rises. Why the temperature rises? Because here current will go on passing continuously. It has some resistance, so due to heating effect, temperature of wire AB may rise. This is simply a wire AB which is connected across a battery B1. Battery B1 through this key K. We can connect ammeter also, ammeter, and a rheostat here. Rheostat actually here act as current divider. Rheostat act as current divider. When we close this key, a certain current I flow this across wire AB. This whole thing is active potentiometer. The battery B1 ammeter connected to measure current key and rheostat. This is RH. Some current will flow, it has some resistance, the potential difference will appear across the wire AB, depending on the value of current, resistance and length. And because rheostat has resistance and this connecting wire also has more resistance, so potential difference will be slightly less than potential difference V volt of the battery, because some resistance is always there. Now suppose you want to measure, this thing is potentiometer. Now what is the working principle? Actually working principle of the potentiometer is based on the fact that when we connect two conductors in parallel carrying different current and different resistance, if we connect an ammeter in the anywhere, तो मान लो ये एक कंडक्टर है, this is another conductor, they are carrying currents, here is voltmeter, and we can connect ammeter also here. So if I1R1 equal to I2R2, then potential reading will be there, but ammeter reading will be 0. If both in parallel, potential difference same. So that fact is used here. How? See. Here, suppose we want to measure EMF of chemical cell, and we connect the polyatomic cell with terminal A. We connect here a galvanometer, and then use jockey here. The jockey can be put anywhere on point AB. The jockey can be put anywhere. Now, suppose this is E. If we find point J, या P कहूँगा actually this is jockey J. Jockey को J कहते J. Jockey nothing, simply conductor. Here the wire is connected here and conducting wire and put this here. You can see in the lab. So we find point P when we place jockey at point P. Galvanometer does not show deflection. If we, by placing jockey at different points of wire AB, we find this point P where touching the jockey with wire AB, voltmeter does not give deflection. How it is possible? Actually, some current I is there. If this length is L, then there will appear a potential difference. And if potential difference between AP is equal to EM cell, no current will be taken out of wheel to this. Have you got my point? If point P somewhere here and potential difference of wire, suppose it is P dash, AP dash potential less than EMF, so current will be given by cell to the circuit and will flow. Deflection current will be one side. And if we go to this point P double dash, okay, where potential difference of AP dash more than EMF, then current will flow through the cell and deflection is the other side. But we find here point P such that galvanometer does not give deflection. It is only possible when potential difference between point A and P is equal to EMF. Galvanometer does not give deflection. If EMF E of the cell equal to potential difference between points A and B. Sorry. If length of wire is L and resistivity of wire equal to rho, and I is the current. Flowing. Then E equal to I rho L upon A. Actually, rho L upon A is R. You know R equal to rho L upon A. I is the current which can be measured by this ammeter. Resistivity of manganese can be known from this 4.4 10 to the power minus 8 ohm meter. Length of wire, here is the scale here, so we can measure by meter scale, and area of cross section this wire by measuring this. So we can measure this EMF when current is not drawn from the cell. When point P is such that galvanometer does not give deflection, then current is neither given to cell nor taken away from cell, and you know V equal to E minus IR. V equal to E minus V का terminal potential difference of cell equal to E. If I equal to 0, V equal to E. Point P here is corner point. Point P here is pole, null point, or balance point. The potential EMF of the cell is measured here in such a manner that when no current is being taken, so it will be exactly. Now here, in equation 1, E depend on current I, length L, rheostat can increase or decrease current. If we decrease current I by taking this rheostat this way, because EM is fixed, rho upon A is constant value. By actually तो E डैश जो है एक्चुअली I L into rho upon A. Rho upon A is constant. If I decreases, then L has to increase. If we decrease current I flowing in the potentiometer wire using rheostat, if I is decreased, then null point will shift away from A, and if we increase I, if I increase, because rho upon A fixed, E fixed, so and you can say or vice versa, and vice versa. Actually, I have discussed here because this question generally asked. If current I is increased, then the null point will shift from A to B or B to A. So it will shift B to A because this product constant होना है, ये fix है. If I increases, L decreases for given EM. Now I come here for a given current I. For a given current I, this I rho upon A is a constant. So we can write E equal to KL, where K equal to I rho upon A. K is constant of proportionality here. Now, for a given current I, for a given wire. Now, from this equation, you can say, but K is equal to here E by L, potential difference divided by length L, is called potential gradient. Potential gradient. For a given current, whether you take potential gradient this upon this or this upon this, its value will be same. Now, potential gradient, volt per meter the unit. Potential gradient may change if you change I. Sensitivity of potentiometer. Every instrument should be highly sensitive so that it can measure the the smallest values also. If we displace the jockey little away from the null point, if there occur large reflection in galvanometer, then potentiometer is highly sensitive. And if on displacing jockey far away there occur small deflection, it has low sensitivity. You can write if displacing jockey little away from null point, there occur large deflection in galvanometer, then potentiometer is highly sensitive, and vice versa. Means if by displacing jockey far away there occur small deflection, then it is lesser sensitivity. And sensitivity of potentiometer, the reciprocal of potential gradient of potentiometer is the measure of sensitivity. So how can we increase sensitivity? We may decrease this voltage of battery B1, but remember, this is called driver cell also. B1 is also called driver cell. The potential difference of driver cell must be more than EM of cell. So we can't go below this. So good option is there, we increase the length. We increase the length of wire AB to increase the sensitivity. You can write it. We can increase sensitivity easily by having a larger length of wire AB. Increasing the length of wire AB, we are increasing sensitivity. Remaining topic I will take in next video. Thank you.